Assalamualaikum warahmatullahi wabarakatuh. Today, my group will present chapter 10, which is carboxylic acids and derivative. So, before we go to the question, we should know that Allah said in Quran, we as a we as a human need to eat halal food. So, the first one, or man can eat from whatever is on earth that is lawful and good, and do not follow the footstep of Satan. Indeed, he is to you a clear enemy. So, one of food is halal that grow in earth is fruits. So Allah said in the next verse in Holy Quran, He causes to grow for you thereby the crops, olive, palm trees, grapevines, and from all the fruits. Indeed, it that sign for a people who give thought. So, for your information, orange is one type of fruits in the world contains carboxylic compound, which is citric acid. We can see that citric acid has carboxyl group. So, question number 2. The first one, name compound J and L. You can see that compound J has carboxyl group that shows it is the highest priority. So, compound J, the name is 2-cyclopentyl ethanoic acid. And for the compound L, we can see that compound L is an ester. It is being produced from compound J react with alcohol, so it produce an ester. So for compound L, the name is ethyl 2-cyclopentyl ethanoate.
Let's proceed to the second question for 2A. So the question is, write structural formula for compound K and M and give the IUPAC name. So, as we know from the previous question, J is 2-cyclopentyl ethanoic acid. It will react with thionyl chloride, SOCl2. The OH atom from carboxylic acid will be substituted by chlorine atom. So the product is an acyl chloride. It means K is 2-cyclopentyl ethanoyl chloride. And for M, 2-cyclopentyl ethanoic acid undergoes hydrogenation process with hydrogen in the presence of nickel and heat to produce an ethanol. So M is 2-cyclopentyl ethanol.
For question 3 Romans, state the observation when J react with thionyl chloride SOCl2. The answer is 2-cyclopentyl ethanoic acid gives out acidic wet fumes, which is hydrogen chloride gas, HCl.
For question IV, use suitable regions and condition to convert J to L. The answer is sulfuric acid and heat, CH3 and CH2OH and heat. It is a formation of ester. Okay, a carboxylic acid contains the COOH group. And in an ester, the hydrogen atom in this group is replaced by a hydrocarbon group of some kind. This could be an alkyl group like methyl or ethyl. Okay. So the alkyl group here is CH2, CH3. CH2, CH3. So the reagent we must include the CH2, CH3, and we must add OH because in this reaction the H will and OH here will eliminate. So the answer the ester we get CH2, CH3. Oh, that's from me.
Today I would like to discuss the question number B1 and B2. So for question B, The question asks to arrange the following compound in the order of decreasing acidity. So before we arrange this compound, we must know what the electron withdrawing groups and what the electron donating group. So the electron withdrawing group is an deactivating group that is attached to a carboxylic ion will delocalize the negative charge, thereby stabilize the carboxylic ion and increases acidity. While the electron donating group is an activating group will destabilize the carboxylic ion and decreases acidity. So for question B1, it has phenol, 1,3-propanediol, propanediol acid, and propanoic acid. So it has diode acid and phenol and ethanol. So to arrange this compound, we must choose the highest acidity. So the highest acidity is propanediol acid, and second is the propanoic acid. We choose. We must know that propanediol acid has the highest acidity than acid, and followed by phenol. Phenol is second last for decreasing acidity, and last is the 1,3-propanediol. Same goes question number B2. The highest acidity is 3-fluoroacetic acid, followed by acetic acid, and followed by 2,2-difluoroethanol, and last the ethanol. So to answer this question, we must know that acid has the highest acidity than ethanol. Carboxylic acid has the highest acidity than phenol. So I hope that all of you can understand for this question. That's all from me.